you'll be taking that quiz, and then if there's time at the end, that's why it's in parentheses, it would be the work time on section 5 and problems 5 and 6 of 13.6 as available. Finishing the gas law station is probably not going to happen. Just a little heads up is, you're going to take CAP classes next year. Please, 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 just go on that website and get signed up. The main reason is you need your Social Security. You need all kinds of info from home. So get that info done, and so you won't be, missing deadlines come fall. There's a whole nother process once you get to the CAP class, but just, whether it's CAP Spanish, calculus, whatever it is you guys are all taking, get that first process done. Now, let's pull out 13.3 because we're going to be working on it. And I see yours somehow got unattached. I would like to check binders, by the way, too, today during the quiz. So, just to show you, I need you to finish section 5. Okay, this is a little bit different from the website, so please do pay attention here. It's a little different, and this is why you physics folks, I'll be looking for all this come Monday. Okay, section 5 on 13.3. Now, pull 13.3 out. I thought when I did it, and I did check the ladies, okay, 13. So you're going to finish section 5 here today as I talk about the combined gas law, okay? That's where you need to finish up, and it's through 35, okay? There's quite a few problems there. And then this was attached, 13.6, okay? Somehow hers did. And what I would like you to do is to finish just problems 5 and 6, just problems 5 and 6. This is all for tomorrow. So that's why we do want to give you some work time, or that's what I'm going to try to teach you, this combined stuff, so you can attack section 5 after the quiz while you're waiting. And then I'll come back and teach you how to do number 5 and 6. Those of you who are on the physics field trip, 1 through 4 will be due Monday. Okay? 1 through 4. All right, so I'll just put that up there. 1 through 4 on 13.6 are due Monday. So again, if you're one of those, Tuesday, we won't be here Monday, right? Okay. Don't you guys feel like it's senior skip day going to physics the day before that break? Wow, what a good time. Anyway, the binder, I'd love to, during the quiz, have you put your binders over on the table there. Like I said, tie-dye, tomorrow's the day, so please wear your tie-dye shirt. And the review assignment that you picked up, it's coded what, C13.8, is due next Wednesday. So start getting, if you, weather's not so good this weekend, so might as well take your chemistry wherever you're going. And that review packet is due the following week. So we're winding it down, but not winding down all the work we're doing. Okay? Questions on what's due? All right, then let's go to, I'll teach you combined, and then I will, I might, with you guys, just because it's recording, I think I might teach you water physics right away too. So let's go to your PowerPoint, and you're going to want 13.2 out. That was the problem set. I'm going to work a problem off of there for the combined. And so your 13.2 is out, and we should be able to get all this. And then I'll teach you a little bit about vapor pressure because it's right along with the PowerPoint. Okay, I'm on PowerPoint. Oh, going the wrong way. Alrighty, talk amongst yourselves while we align the smartboard. Okay, it's blinking. 1, 2, 3, 4. Maybe this is a little better. Okay. No, we don't want ideal. That's what you're going to miss, by the by, for Friday. So maybe we can talk about that. Today's quiz is going to be on these gas laws. Okay. On these gas laws, Boyle's, Chuck's, Gay-Lussac's. You remember that the only one that's inverse relationship is Boyle's. The other two are going to be direct. And these are the mathematical expressions. And again, today we're not, but on the test we'll ask you, or next week I believe you have another quiz, we'll ask you what was held constant in each of these. Okay, we will ask you that. So, what happens when you combine these? What happens when you combine these three gas laws? Well, you get the combined gas law. Okay, all three of the previous gas laws can be combined into one. And it's called P1 V1 over T1 then would be equal to P2 times V2 over T2. And you're going to be given 5 out of 6 variables here. And you're going to, you can solve for any problem using the one equation. And so that's what we're going to do here is solve. We're going to give you problems, and here we go. We don't write much because it's really hard to write, so we're just going to work these out with you. The combined gas law, you're going to practice rearranging. I'll solve for P, I'll solve for T. I might not get to both of those, but I'll at least solve for one. So here we go. I'd like us to, that's our PowerPoint note. Now let's go to 13.2, and I'm on here. Where I'd like us to work is on page 3, the bottom of page 3. So, if I initially have a gas, no, that's gave combined, it's down on the bottom, right on the very bottom. The combined gas law combines Chuck, Boyles, and Gay-Lussac's. In each of these laws, pressure, temp, and volume must remain constant. In the combined gas law, any of these properties can be found mathematically. Just down here one time, Tyann, tell me what is the mathematical expression for the combined. So this is on 13.2, the bottom of page 3. And what is the mathematical expression for the combined gas law? P1 V1 over T1 equals, you got it. Good. Okay, so that's what we want. Now let's flip over to page 4. And up there, Ryan, it says a gas takes up a volume of 17 liters, 2.3 atm, and a temperature of 26 degrees Celsius. If I raise the temperature to 72, lower the pressure to 1.5, what is the new volume? What's step 1 in my six-step method that you'll show me on the quiz? Step 1 is always the same. And what are they then? Okay, well tell me what they are. So, on the top of page 4, on 13.2. Top of page 4, 13.2 is my problem. Yeah.
Okay.
No, I have a volume of, okay, it's 13.2, look like this. It was way back. Here, he's ready. We'll come back to you once you find it. Andy, what do you think? What's V1 on that problem? 17 what? Liters, okay. And what else are you? Good. That's our unknown. .3 what? ATM. Good. Well, and again, let's try and make those 3 sig figs if I didn't. Okay. Good. And good. Uh-huh. All right. You find it now, Ryan?
Yeah.
Okay. So I'm going to make you do the conversion. Please remember these gas laws relationships do not work unless you have the temperature in Kelvin.
Q1 is 299 Kelvin.
Yep. And no degree sign, just the Kelvin.
And Q2 is 348 Kelvin. Oh, no, I didn't study that. 39.
Okay, so don't make little mistakes on today's quiz, right? Get those calculators warmed up, ready to go. Alrighty. So now, what is different here then is I have 5 out of 6 variables, meaning different from today's quiz. Today's quiz, you'll have 3 out of 4. Our next quiz are going to be all, it's a mixed bag, so it'll be all these. So what are, bless you, you give me 2 rectangles. What are the 2 rectangles? So this is step 1, is you set up your variables. Step 2, I would like those 2 rectangles. And what would they be then? And that's why, again, I like to stack them, because it's easier to find the relationship. Pardon me? What do I have 2 pieces of information about? Right, so P, do a rectangle with P first, and it's pressure went down. Therefore, what effect will that have on this unknown I'm looking for, volume? Up, good. Don't forget that. Whose law? Good, okay. How about the rectangle, Aubrey, for temperature? Okay, therefore, good, okay. Now, they don't have to both force the volume to do the same thing. As I talked about yesterday, sometimes you might have a tug of war. One or the other is going to have the bigger influence here. One or the other is going to have the bigger influence. Okay, so that's step 2, okay. Step 3 is, what's that mathematical relationship, Connie? Okay. I find that you guys seem to be able to do this a little quicker than some other groups, but then let's rearrange. Step 4 would just be to rearrange to isolate the variable I want. So what would that look like, Jessica? Okay. P1, V1, T2 over P2, T1. Good. All right, so again, that's for those of you that can't follow what we're going to do in the next step, which is step 5, okay? So but if some of you do love your math and you want to put all those expressions out there, great. Like I said, this is what I grade on today's quiz or the next quiz. 1 point for your variables, 2 for those rectangles. Then I hop right to step 5, which is, Jessica helped us out there by rearranging that. But this is where our little work really helps us. V2 is always going to be equal to V1. Okay, so V1 is 17.0 liters times, this time now, 2 conversion factors. Because if I have 2 rectangles, I'm going to have 2 conversion factors, just like, very similar to our box diagram, that are going to force the volume up. So how do I set up then, Casey, how do I set up my pressure so it will force volume up? Here's my pressure numbers. Is it 2.3 over 1.5 or 1.5 over 2.3? Okay, look at where the tip of the second arrow is pointing. That means put your bigger number where the tip of the second arrow is pointing. 2.30, and again, like we said, yep, over the 1.50 ATM. Okay? That's our, now, that is, what are you doing? You're doing this. You're doing this. You're putting P1 over P2. Okay, Robert, what about my temps? How should I set those up?
345 over 299.
Yeah, 345 over the 299K. Again, what happens is that some of you fall short on some of that work with your algebra in steps 3 and 4. So this way, it's much cleaner too. Remember on today's quiz, I want you to cross out those labels. I want you to cross out those labels, and that's what gets messy here, okay, is when you're doing that, is if you set it up all like this, finding labels to cross out isn't always your best suit. Sean, can you crank those numbers for us, please?
I got 30.
30 point, okay. Now, I have 3 sig figs in my given. Now it's easy to see my given. So what would that be? You bet. V2 is 30.2. 1.1. And again, what's my label? Well, these guys crossed out, so it's got to be liters. Robert, you had a question.
You have to do stuff like that.
Yeah, I'd like them isolated.
You don't have to do it.
Because I'd like you to make sure you cross out those labels. It really helps you find those labels and cross them out when you isolate those two conversions like that. You're doing this. You're doing this. Okay? Okay, you're doing this, but I have to see that those labels are crossed out. It's much easier to see it like that. Yes, prefer that. Questions? Okay, there's a couple on your homework on 13.3, which is why after the quiz, go ahead and start attacking those on 13.3. Like I said, normally I'd give you the quiz right now because we want to and then I try to draw you back, but not today. I'm going to take advantage of your good attention span right now, and I'm going to move on to the next topic. So let's fill in a few slides on PowerPoint. Keep this out, 13.2. Excuse me. So let's talk about the next one, which is actually they're not just next. Vapor pressure. Let's talk about some vapor pressure. So we're going to, tomorrow, by the by, physics folks, we're going to cover ideal. So you will miss those. Ideal, though, is really, you'll feel fine. It's plug and chug. Write an equation and plug and chug those variables. Okay? So ideal, you're missing. I'll talk to the rest of you about that tomorrow. And again, I will have that. Okay? Oh, don't forget this. Oh, that's a good time to remind her. I don't know if I did it to you on this quiz, but maybe the next one. STP. Okay? ST, standard temperature, is 0 Celsius or 273 K. Standard pressure is 1 ATM, 101.325 kilopascals, and 760 millimeters of mercury. Again, just in case I ask you to do that. Now, what that leads into, though, is here. I'm going to go beyond this, beyond ideal. Where do you make mistakes? There's the ideal. We're going past Dalton. Okay. And let's collect a gas over water. All right? Collecting a gas over water. Slide on your PowerPoint. One below Dalton. Bless you. Come on. All right. Here we go. This is something that we've done a ton in the past, is how can I capture a gas? You know, and then mass it out or do something with it. Well, you can put a balloon, like you guys at that one mini gas station over there. You put the rubber glove over the top, and then you saw that it kind of grew and turned into a balloon. You could take that balloon and you could mass it on a balance, but it's really not accurate. The best way to capture a gas is over water. So we collect a gas over water. Dalton's law will come into this. You'll see here in a bit. But this was the gummy worms. Remember when I did gummy worm? You remember because Alex and Jared were helping us. I heated up a ton of potassium chlorate. Bless you. And it spewed when we threw a gummy bear in, it spewed out, that demo. Well, now, don't let it spew out. Go ahead and stopper that, capture it with a tube, and have a tank of water that you've inverted another chamber that contains water in it. Okay? And what will happen is once this reactions, the gas is given off, it will displace the water in this tube. So I'm going to have to, it's one thing to talk about all this, but I'm going to have to borrow you, Zach, because I got to change. Can you turn off that audio? I do have a It's also going to be the pressure then is where, okay, going in the wrong direction. Okay, it's also going to be the pressure due to the water. So, since gases will mix with all kinds of other gases, air, right, has all kinds of other gases. So, since they mix, mixing cannot occur. The easiest way to do this is underwater. We'll displace the air. When the gas is collected over water, filled with water, and the gas is bubbled through. Thus, the pressure in that chamber is due from the gas and the water vapor. So what's your job? Well, your job is going to be here. Here's that vapor pressure. There's those molecules. They're escaping out into the vapor phase, and then they're going back. But there's also water. Mickey's there. Mickey Mouse. Water is there. And he's going back into the liquid phase and up into the gaseous phase. So your mission is going to be one little thing when you do a vapor pressure problem. And that is you're going to take the pressure that we report in the room, and you have to subtract out the vapor pressure due to water at a certain temperature. And that will give you the pressure of the dry gas, meaning only your gas, the red ones, not the red and the Mickey, the water vapor particles. Okay? Now, we give you charts, okay? We gave you charts. I believe they're on your, back on 13.2. You kind of left that sitting out here. Okay, on 13.2, on the bottom of page 4, there is a chart, and you can see here that the problem here is that the vapor pressure at certain temperatures is going to be given in millimeters of mercury, and sometimes our problems are going to ask you to convert to here some atmospheres, so you are going to have to do that. So, here's what happens. Collecting a gas impact your gas law problem. A student collects some hydrogen gas over water at 20 Celsius, 768 mmHg. What's the pressure of the dry gas is how they'll read. Your job is to go to this chart, if I don't give you the number in the problem itself. And if I do, I usually write it like this. VP water, the vapor pressure of water, at, for example, this problem said 20, right? At 20 degrees Celsius, let's look on our chart here. If I don't give it to you, you would have said it's 17.5 mmHgs. Okay, so 17.5, you look it up on these tables, and then what you have to do is subtract that from the initial pressure. So if I tell you the initial pressure is 768, you go to, but it's collected over water, all you have to do is subtract out the mmHg due to the water, millimeters of mercury. And so your new P1, usually it's P1, becomes 768 minus 17.5, 750. Okay? The problems, then you would just do, what most of those problems just ask you to do then, is a combined. So let's go to the top of page 5. Did that one give you a VP1? Yep. Okay, top of page 5 here real quickly. And I think I'm too, did I get Matt? Help us out here. Okay. To top of page 5 on 13.2, just to give us top of page 5, 13.2, given that 0.85, so our example, page 5. So V1, yep, 0.850 liters, right? mmHg, now, okay. Yeah, we do. STP, here's that trick I always said. Got to memorize that. I'm going to use mmHg, so good. Class is helping him out. 760 mmHg. What else is given? Yeah? Right away, go ahead. 294K, good. And T2? Okay. Yep, man. 273. Got to memorize those two values, okay? 1 atm, 0 Celsius, aka 273. Okay, now one more little thing. This liters of oxygen is collected over water at 21 degrees Celsius. So yes, 21 got me T1, but what else, Kaylee? If it's a gas collected over water, what do I have to do with my chart on the previous page and that 21? I need mmHg at 21 Celsius. And what do I do with that 18.6? So what she just told me, and again, sometimes in a problem, I would write VP water at here, 21 degrees Celsius equals 18.6 mmHg, just as another piece of info for the problem, or in this case, you got to look them up. So then what would you do with that info? Okay, Caitlin, what do we do with that? 18 and a half, or 18.6. Get that last slide on the PowerPoint. What do we do? Yep, you take your T1, or your P1 here, that we have, and you subtract that 18.6 mmHg. When you collect over water, you have to subtract out the vapor pressure due to the water. We just want the dry gas. And so now P1 becomes what? 2 is going to give us this value. You got it. 733.4 mmHg. Then it becomes a combined. All right? So this was your new step. Your new step is gas over water. That then have to subtract out the vapor pressure of water at that temperature. Then it'll just be 2 rectangles and setting up and solving for V2 with 2 conversion factors. Just a little FYI, this one, once you go to solve it by step 6, should come out to be 0.762 liters. Okay, just if you want practice. Alrighty, then that's enough for today. Let's give you that quiz, and then when you're done, please bring your quiz over to bench 1, and then you can get to work on the other